Welcome to the math record. Today I'll be covering the derivatives of trigonometric functions. So these are your sine, cosine, tangent, cosecant, secant, and cotangent. So basically there's only two of them that you need to know, the sine and the cosine. Everything else you could get from there. Um, so I'm just going to give you the sine and cosine. So let's say we're given f of x is equal to sine of x. The derivative of sine of x is cosine of x. And we're given f of x is equal to cosine of x. The derivative of cosine of x is negative sine of x. So sine becomes cosine and cosine becomes negative sine. Okay, so let's try to find tangent. So in this video, I won't be using a bunch of examples. I'll just explain the process of how to get every single one of them, so you don't have to like memorize a bunch of formulas. So if you ever want to do it, just kind of follow this process again. Once you get used to it over and over again, it's just gonna become muscle memory, and you're just gonna do it really quickly. So cotangent of x, I mean tangent of x is sine of x divided by cosine of x, which is just sine of x times cosine of x to the power negative 1, what we did with our quotient rule. So now we're just going to use the product rule, turn this quotient rule into a product rule and a chain rule. So the derivative of our tangent is derivative of our sine, which is cosine, multiplied by whatever is left over, plus keep the first one the same, and derivative of our second. So we need to chain this because number, so we use the power rule because it's a variable base and the number exponent. So it'll be negative 1 times cosine of x. So negative 1 minus 1 is negative 2. And then we chain it from inside. So cosine of x, the derivative of that is negative sine of x. And now we just simplify. So cosine times cosine is, oh, sorry, this is to power negative 1. So that's cosine of x. So this is reciprocal, actually. So that's cosine of x plus sine of x. Negative 1 times negative sine of x is sine of x. So sine of x times sine of x is sine squared of x. And then we have cosine of x to the power negative 2. So that means the bottom is just squared twice for cosine. Now to simplify this, we just need to multiply the top and bottom by cosine of x for this one. So this becomes cosine squared of x over cosine squared of x plus sine squared of x over cosine squared of x. Cosine squared of x plus sine squared of x is 1. So then we just have cosine squared of x on the bottom. So that means the derivative of our tangent of x is just secant squared of x. Because 1 over cosine is secant. And since it's squared, that means secant is squared. So the derivative of tan is secant squared. Okay, now let's use cotangent. So f of x is equal to the cotangent of x. So this is just reverse of tangent. So now it's cosine instead of sine on top. So we have sine on the bottom now. And then cosine of x times sine of x to the power negative 1. Take the derivative of this. So derivative of the first one. So derivative of cosine is negative sine multiplied by the same thing of the second plus keep the first one the same. And then derivative of our second. So the power rule because variable base number exponent. So negative 1 sine of x. Negative 1 minus 1 is negative 2. And derivative of what's inside because we need to chain it. So that's cosine of x. So now we just need to simplify. So we have negative sine of x. So sine of x to the power negative 1 is just reciprocal. So sine of x plus, and then we have cosine of x, negative 1 and cosine of x. So that's negative cosine squared of x. And then sine x to the power negative 2. So that's just sine squared of x on the bottom. And then you simplify this by multiplying this by sine of x. So that's negative sine squared of x divided by sine squared of x plus negative cosine squared of x and sine squared of x. So yeah, similar denominators. So negative sine squared of x plus negative cosine squared of x, that's just negative 1 over sine squared of x. That means the derivative of our cotangent of x is negative cosecant squared of x. Because 1 over sine is cosecant. Since it's squared, that means this is squared. And that's basically it for cotangent of x. Sorry. Okay. And now finally for secant and cosecant. So let's start with secant. So secant of x is just 1 over cosine. So we could convert that to cosine of x to the power of negative 1. And the derivative of secant, which just means we need to take the derivative of this. So variable base number exponent means we use the power rule. So negative 1 times cosine of x. Negative 1 minus 1 is negative 2. Derivative of cosine of x is negative sine of x because we need to chain it. So that gives us negative sine of x times negative 1 is sine of x on top. And then cosine of x squared on the bottom. So I'm going to rewrite this as sine of x times 1 because multiplying by 1 does nothing. And I'm going to split cosine of x. Cosine squared of x is cosine of x times cosine of x. So sine of x divided by cosine of x, that's tangent of x. And 1 divided by cosine of x is secant of x. So that means the derivative of secant of x is tangent of x times secant of x. And then our final one, which is cosecant of x. And it's the same thing, so 1 over sine of x equals sine of x, power negative 1. So the derivative, so variable base, number exponent means power rule, so negative 1. So sine of x, negative 1 minus 1 is negative 2. And then we need to chain it, so derivative of sine of x is cosine of x. So we have negative 1 times cosine, which is negative cosine of x. So sine of x to the power of negative 2 is just sine squared of x on the bottom. We're going to rewrite this as negative cosine of x times 1. Then sine of x times sine of x. So we split sine squared of x to just sines. Cosine of x divided by sine of x is cotangent of x. So we still have that negative. So negative cotangent of x multiplied by 1 over sine of x. That's cosecant of x. So that means the derivative of cosecant of x is negative cotangent of x times cosecant of x. So that is the process how you're going to be able to solve all of them. And we're just going to end this video with an example. So I'm just going to do something simple with sine of x. So let's say 5 sine of x plus 3 cosine of, let's say, 2x. So we take the derivative of this. So 5 is a scalar, so we just leave it alone. So derivative of sine is cosine. So 3 is a scalar, so we leave it alone. And then derivative of cosine is going to be negative sine. But it's not just cosine of x, it's cosine of 2x. So we have a function inside the cosine. So a function inside a function means we need to chain this. So negative sine of, so multiplied by negative sine of 2x, we leave that alone. So the derivative of 2x, which we need to chain, is just 2. So that means the derivative of f of x, the derivative of f is just 5 cosine of x. 3 times negative 1 times 2, this is actually a negative 1. So that's negative 6 sine of 2x. And that is going to be the derivative. And one thing we're going to add is that whenever you're in calculus, you are never going to use degrees. You can use degrees to convert to radians, but you're never going to use degrees when you're doing calculations. So you can't write functions like, let's say, something that has scaled up by 360 degrees. So you can't say like sine of 360x because you think it's 360 degrees. No, you're going to be working with 2 pi x. So we're going to be working with radians instead of degrees. If you don't know what radians are, it's actually pretty simple. Basically, 360 degrees is equal to 2 pi radians. And if you ever want to find any other degrees, you just need to use this conversion. So let's say you want to find 30 degrees, right? How do you get from 360 to 30? Well, you need to divide by 12. So that means 2 pi divided by 12 means pi over 6 radians. So you're gonna so instead of plugging instead of using degrees, you're always gonna use radians. So if we wanted to find like let's say the derivative of this function at like 180 degrees, well we're not gonna use 180 degrees. 360 divided by 180, that's 2. So that means 2 pi divided by 2, we're using pi radians. So 5 times cosine of pi minus 6 times sine of 2 times pi, which is just 2 pi. So cosine of pi, that's negative 1, minus 6 sine of 2 pi is 0. So 5 times negative 1 is negative 5. That means the derivative or the slope at x is equal to pi is going to be negative 5. And that basically covers everything for this video. Well, thanks for watching, and I'll see you at the next video for the series.